Hello everyone. So welcome to the course Mastering in Computer Graphics from Pixel to Virtual Worlds. So in this module, we'll begin our study in visible surface detection methods, one of the most important topic in the 3D graphics and rendering. So in this session, we'll be discussing why visible surface detection is necessary and key concept and definition and classification and visible surface reduction algorithms, a difference between the object space and the image based methods. So let's begin. So coming to the why we need a surface reduction. So imagine in a complex three-dimensional scene contains many objects like buildings, vehicles, trees, people, many things. So when a viewer looks at the scene at a particular angle, not every surface is visible. Some of the surfaces are hidden or behind to other people. For example, if a building stands in front of the another building, so rear building may not be visible. So it may be hidden from the view. So if a computer renders every surface, including those cannot be seen, so it wastes of processing power and memory resources. So therefore, we need a mechanism to determine whether which surface is visible, which is not visible, or which is hidden. So this process is known as visible surface detection or hidden surface elimination. Okay. So the primary objective to render only the portions or objects that are visible to the viewer and improving both efficiency and visual correctness. Okay. And coming to the um, key definitions. So first one is visibility culling. So visibility culling refers to the identifying surfaces that are visible from the camera's viewing point. So the graphic system processes only the surfaces that contribute to the final image. And next one is hidden surface elimination. So this is the process of removing the surfaces or portions of the surfaces that are blocked by the other objects, which is not visible. And the third one is shadows. Shadows are closely related to the visibility. Uh, Instead of determining the visibility of the camera's angle, the shadow algorithms decides visibility from the perspective of the light source. If an object looks from uh, reaching another surface, yes, a shadow may be produced. So these concepts are fundamental to understand the realistic of computer graphics, how the computers are rendering the images. And now, visible surface detection algorithms can be broadly divided into two categories. So, first one is object space method, and second one is image space method. So, first let us see the first category, object space method. So, in this method, visibility calculations are done by directly on the geometric objects before they are converted into pixels. So the algorithm compares the polygons, edges, surfaces, entire objects to decide which portion is visible. Okay. So since calculations are performed using the actual object area, these methods work in the coordinate space of the scene. Say, for example, the 3D space. The example, if you take a backspace reduction, BSP tree method, so these are all area distribution method. So these are all some object space method. Moving on to the second category, image space method. So these methods determine the visibility at the pixel level, point by point. Instead of comparing the complete entire object, this algorithm examines each pixel. Pixel means a picture element, point by point. So pixel position on the screen is actually taken to consideration whether it is visible or not, or the object should appear or not. So in image space method, the widely used because it is very efficient, easy to implement, and well suited for modern graphics hardware. So the example for this algorithm are a deep buffer or Z buffer method, scanline method, ray casting method, ray tracing method. So these are all some examples for the image space method. And now we are comparing the two approaches, image and object space method. On processing text, object space methods focus on objects, polygons, And coming to image space method, focus on the final pixel on the screen or on the grid. So in terms of object handling, the object space methods, each object is processed and compared with the other object. Whereas in image space method, each pixel is examined and assigned to the visible surface. And taking the computational challenges or drawbacks, so object space methods may repeatedly draw the same pixel location, causing the some additional computation. Whereas in image space, um, so in this method, they may repeatedly compute the visibility information for many pixels. For many, one, if you take one picture, it may contain number of pixels. So it has to do the same process for each pixel. So that also a drawback. So that is what the comparison. And so in this session, we learned about the visible surface detection method, which determines the which surface are visible to the viewer, and the category and comparison between two methods.